Okie doke, 1-4, quadratic equations. Probably will not finish this in one class period. It's up to you to let me know if I need to speed up or slow down. If I don't hear anything, I'm going to assume that the pace is great for everyone. Okay? Zero factor property, we're going to talk about that first, and the square root property, and completing the square. We should finish all three of those today. And then that would leave quadratic formula, solving for a variable, and the discriminant for tomorrow. If I get further than what I've mentioned, then I will. That's fine. But I'm thinking 2 days on this lesson. Okay, remember a quadratic equation is going to take the form ax squared plus bx plus c equals 0. That's going to be a quadratic equation. It must be in that form before we factor it. Once it's in that form, we can factor it and set those factors to 0. If it is easily factorable, that means we're going to take a quadratic and write it as two separate factors. If I have two things that are multiplied together and get 0, what does that tell you about the factors? How do you multiply two things together and get 0 as an answer? One of them has to be 0. Okay? That is called the zero factor property. Chances are I'm not going to use that term, but when you're doing your homework, whatever, if it says use the zero factor property, what it's saying is factor it, set the factors to 0, solve. Okay? Pretty simple. So if a and b are complex numbers with a times b equals 0, then either a or b or both are 0. Here is a quadratic. We're going to use the zero factor property to solve 6x squared plus 7x equals 3. What is the first thing I have to do to this to solve it? Why? To set it equal to 0. So to set this equal to 0, I have to subtract 3 from both sides. Subtracting 3 from the left side gives me 6x squared plus 7x minus 3 equals 0. Subtracting 3 from 3 gives me 0. Y'all good with that? Now let's determine if it's easily factorable. Does 6x squared plus 7x minus 3 factor? How do we find out? Just snowflake it? Top center, a times c is 6 times negative 3, negative 18. Bottom center, b is 7. Top left and top right, 6x. We take the leading coefficient and the variable and half the exponent. So half of 2 is 1. What goes in the bottom left and bottom right? 9 and negative 2. Because 9 times negative 2 is negative 18. 9 plus negative 2 is 7. Next step. Okay, simplify, reduce if possible. The 6x and 9 become? 2x and 3, because 3 goes into 6 twice, 3 goes into 9 3 times. 6x and negative 2 becomes 3x and negative 1, because they both reduce by 2. 2 goes into 6 3 times, 2 goes into negative 2, negative 1 time. So this factors into 2x plus 3 times 3x minus 1 equals 0. Do what? The light just came on? Okay. I have two factors, right? I have two things, two factors multiplied together to get 0. The only way that's possible is if 2x plus 3 equals 0 or 3x minus 1 equals 0. Solving 2x plus 3 equals 0, what do we do? Ready, go. Good. Get the x by itself. Step 1. Step 1. Subtract 3 from both sides. 2x equals negative 3. Now, x equals negative 3 halves. Or, add 1 to both sides. 3x equals 1. Divide by 3. X equals 1/3. And how do we enter this answer on the homework? Okay, I think the homework gives you the brace already, right? And it's got a box in there? Yeah. Okay. Yeah, negative 3 halves, comma, 1/3. Yes, because 1/3 is not 0.33. It's 0.33333, and you don't have time for that. Yeah. Questions on this? Okay. Make sure when you're entering your answer, the comma is not in the fraction. I've seen that done before. You have negative 3 over 2 comma. So the comma is in the denominator. So make sure you're out of the fraction. Sometimes it's hard to see, especially on the small fonts on the computer. Any questions on this? Okay. Has anybody tried to enter the numbers backwards, entering the big one first? Okay. It's a bad practice. I don't know if the computer would take it. It's better to put them in order from smallest to large. Okay. If I can write a quadratic in the form x squared equals k, I've got x squared, which is a perfect square, equal to some constant k, some number. If that happens, we can use what's called the square root property. Typically speaking, there's not going to be a linear term. Like instead of having ax squared plus bx plus c, the bx will be gone. If the bx is gone, it's very, very easy to use the square root property. To do that, you get the constant by itself and then take the square root of both sides. Now, here's where you've got to be careful. Let me change this to fit slide. Best fit. Okay. I want to know this answer. What is the square root of 49? 7? Does everybody agree? Everybody agrees, yes? Okay. If I say that x squared is equal to 49, and we're solving this quadratic to get x by itself, what do I have to do? Take the square root of both sides, correct? What's the square root of x squared? X. What's the square root of 49? Try again. See, here's the problem. We're now trying to find a value of x. We're now solving a quadratic. Look at this exponent. The highest exponent in a polynomial tells you how many solutions there are. So if you tell me x equals 7, how many answers did you give me? 1. It's a quadratic. How many answers are there? 2. So now what's the answer? Plus or minus 7. That's 2 answers. Okay, does that make sense? Just asking you what's the square root of 49, the answer is 7. But if I'm solving a quadratic, x has two values. If you don't like it, just throw it in the floor. Okay, I've been told that it actually accepts them both ways. You can either write this or type this as -7, 7. And I think, maybe not on all of them, but I think on some of them, once you click on that box, a little window on the right side will pop up. Okay, and you can hit that plus or minus button and then a 7. And I've been told that it accepts both. Okay, that's what I've been told. I thought this one, I thought plus or minus didn't work, but second period I was told that yes, that does work. Okay. Any questions on this? Solving a quadratic. It's a second degree polynomial, therefore there are two answers. Okay. X squared equals 17. I want to know the value of x. Is x squared by itself? Yes. Do I have a constant on the other side? Yes. How do I get x by itself? Square root both sides. The square root of x squared is x. What is the square root of 17? Okay, great. It is going to be a plus or minus. So before you even worry about what the square root of 17 is, don't forget we're solving a quadratic. It must be plus or minus. Is 17 a perfect square? No. Are there any perfect squares that go into 17? No. Well, 17 is prime, right? So what's the square root of 17? It's the square root of 17. That's what it is. Okay. Y'all good with that? You can't do square root of 17 in your calculator and get 4.1 or whatever it is. You can't type that in. It wants the exact answer. Now, if it said, give me the answer to the nearest tenth, could you use your calculator? Sure. You could round to the nearest tenth. Okay? But you can only round if it asks you to round. Otherwise, give me the exact answer. However, don't ever tell me you ate the square root of 17 items. You would tell me you ate a little bit more than 4 of something. Okay? I had 4 pieces of candy and I licked the 5th one. All right. B. X squared equals -25. Okay. Do I have x squared equals k? Yes. To get x by itself, square root of both sides. Square root of x squared is x. Square root of -25 is? You're telling me that 5 times 5 is -25. Is 5 times 5 -25? No. Okay. First of all, it needs to be a plus or minus, correct? I'm going to go long on this. Does everyone agree that -25 is the same thing as -1 times 5? 25. Does everyone agree? -25 is -1 times 25, yes? Okay. Would you agree that the square root of -1 times 25 is the same thing as the square root of -1 times the square root of 25? Do you agree with that? Yes. Okay. Let's do the second one first because I think you're more comfortable with that. What is the square root of 25? 5. What is the square root of negative 1? What is it? Imaginary. So what do we use to represent imaginary? I. Okay. So the answer is x is equal to plus or minus 5i. By definition, the square root of negative 1 is I. Okay. Questions on part B? The square root of negative 1 is always going to be I. So the square root of negative 36 would be 6i. Square root of negative 4, 2i. All good? Okay. Part C. Sorry about the overlap on the text here. I have x minus 4 squared equals 12. X minus 4 squared equals 12. Is x minus 4 squared a perfect square? It's kind of in the name, right? If something is squared, it's probably a perfect square. Okay, so x minus 4 squared is a perfect square. So if I took the square root of x minus 4 squared, the square root would cancel the square, right? So the square root of x minus 4 squared is x minus 4. But if I take the square root of the left side, I have to take the square root of the right side. And this is going to involve a plus or minus, right? Because I'm still solving for x. It's still a quadratic. There's still two answers. Is 12 a perfect square? No. Are there any perfect squares that go into 12? Yes. What? Okay. X. Just 4, right? I heard 4x for whatever reason. So would you agree that I could rewrite 12 as 4 times 3? 4 times 3 is 12. Okay. And again, guys, I'm working these out. I'm taking baby steps. If you can skip some of these steps and still be successful, I don't care. All right. What is the square root of 4? 2. What is the square root of 3? It's the square root of 3. Okay. Notice that when I took the square root of 4, my answer was 2. I don't know why, but I've seen students in the past tell me that the square root of 4 is equal to the square root of 2. No, you use the square root. There's a reason. It's gone. Once you use that radical, it's gone. Am I done? No, because x is not by itself. How do I get x by itself? Add 4. So x equals, I'm going to write the 4 down first because this other stuff is a little ugly. 4 plus or minus 2 root 3. Questions, comments, thoughts? Are we bored? Are we going too slow? Y'all okay? Everything good? Okay, moving on. Completing the square. To complete the square, you're going to take a quadratic that's not a perfect square and make it a perfect square. Hence the phrase, completing the square. Do y'all remember doing this last semester? Who does not remember completing the square? Okay. Many of you weren't in my class last semester, but I'm going to draw a perfect square on the board. And if you had me last semester, you might remember this. Okay, there, that is a perfect square, right? Four sides, all four sides exactly the same length. Agree or disagree? Disagree. It's not perfect square. Can you come up and make it a perfect square? Can anybody come up here and make that a perfect square? I believe in you. What do you want me to do to make it a perfect square? Huh? What do you mean? I don't understand. Well, that is a perfect square. Is it now a perfect square? Work with me here. Work with me. Is it now a perfect square? What did I... Hey, I'm using the term perfect very loosely. Okay, correct. What did I do to complete the square? What did I do to make it a perfect square? What did I do right here to make it a perfect square? Don't think too hard. State the obvious. Do what? I added a piece. I added a piece. In algebra, to complete the square, you will always add something. That's how you complete the square. What's so funny? What did I miss? Okay. To complete the square, you add something, correct? Okay. I'm not going to go through all these steps. We're going to look at some problems. I want to solve x squared minus 4x minus 14 equals 0 by completing the square. Step number 1. Is A 1? Ax squared plus bx plus c. Is A 1? A is clearly 1. Good. Next step. Is negative 14 a perfect square? So I guarantee this is not a perfect square. So to complete the square, I have to get rid of the constant. I need to get rid of that minus 14. To get rid of that minus 14, I will add 14 to both sides. Now, as I do this, stay with me here. I'm going to write x squared minus 4x. I'm going to leave a space because to complete the square, I've got to add something. And that something is going to go right there. Equals, adding 14 to both sides, I get 14. Any questions there? All right. Now, as I proceed with this problem, I'm going to use colors. I'm going to use colors for a reason. And when I get done with this problem, if you want to take a picture of it so you can see have the different colors, that's cool. Or you can watch the video back on YouTube. What is B? What is B? Negative 4. Remember, quadratic is a x squared plus b x. X is not part of b. X is attached to b. Okay? What is half of b? Negative 2. What is half of b squared? 4. Is 4 a perfect square? Yes. To make x squared minus 4x a perfect square, I have to add something. What do I have to add? I will add 4. But is my equation balanced? See, I had a balanced equation, and then I added 4. I'm not balanced. How do I balance it? You're thinking of something else? Add 4 to the other side. Right now we're dealing with an equation. Okay? I understand what you're saying about adding 4 and subtracting 4. That's a different thing that we do in this class. But because I have an equation, if I add 4 to one side, I have to add 4 to the other side to keep it balanced. Any questions so far? Completing the square is a step-by-step process. We always do the exact same thing all the way through. Sometimes it gets complicated or a little hairy looking. Okay, it's not difficult though. Okay, so we made the left side a perfect square. X squared minus 4x plus 4 factors. It's a perfect square. And let me show you what it factors into. It's always going to start with x. I'm changing colors. What two numbers multiply together to get 4, but add together to get negative 4? Negative 2 and negative 2. Okay? That negative 2 goes right here. Squared equals 18. When you factor your perfect square, it's always going to be x half of b. So if half of b was positive, that would have been a plus 2. But because b is negative, it's a minus 2. Doesn't this look almost exactly like the last problem we did on the last slide? Just different numbers, right? Okay. Square root of both sides. Square root of x minus 2 squared is x minus 2. Square root of 18 is plus or minus. Let's start with that. Right? Plus or minus. Yeah, but you're spot on there. Plus or minus the square root of. 18 is not a perfect square, but you said there's a 9 in it. 18 is the same thing as 9 times 2. And we chose 9 because 9 is a perfect square. So x minus 2 equals plus or minus square root of 9, 3. Square root of 2, square root of 2. Can't do anything with it. Next step, add 2 to both sides. X equals 2 plus or minus 3 square root of 2. How we doing? Okay. Ready for an ugly one? Guys, the steps are exactly the same. Okay. 9x squared minus 12x plus 9 equals 0. What is a? It's not 1. It's 9. But I can make it a 1. How can you turn a 9 into a 1? Can't subtract. Divide everything by 9. So if a is not 1, here's the first step. If a is not 1, you divide everything by a. So I will divide everything, all 3 pieces, by 9. 9 divided by 9 is 1. There's x squared. Minus 12 divided by 9. Do not use decimals. 12 divided by 9 reduces to 4/3. 4/3 x plus 1 equals 0. Is a 1? Yes. A is now 1. So at this point, I need to get rid of that c value. So I need to subtract 1 from both sides. Make sure you leave a space. Squared minus 4 thirds x, leave a space, equals -1. Did anybody want to take a picture of that last slide? Anyone? Okay. All right, here we go. What's b? -4/3. What is half of -4/3? What's half of 4/3? What's half of 4 apples? 2 apples. So what's half of 4/3? So -2/3? What is half of b squared? -2/3 times -2/3. That's multiplying by 2. Negative times a negative is going to be a positive. 2 times 2 is 4. 3 times 3 is? Okay, there you go. -2/3 squared is 4/9. And guys, use your calculator. Okay? You only have a set amount of time to take your tests. Use your tools. If you don't finish a test during the class period, whatever you don't answer is going to be counted wrong. There are no corrections. Okay? All right. So what do I have to add to both sides to complete the square? I have to add this perfect square, which is 4/9. Yay, we're going to factor something that has fractions in it. Ooh, ah. How difficult is this? Remember, it's going to factor into whatever the variable is. And then what do I write down? Half of b, which is -2/3 squared equals -1 plus 4/9, -5/9. Pressing on. Okay. Can I take the square to the left side to get rid of the square? If I take the square root of the left side, I take the square root of the right side. Left side becomes x minus 2/3. I got the square root of a negative. What's going to happen? There's going to be an I. Okay. I'm going to write this off to the side. The square root of 5/9 is the same thing as the square root of 5 divided by the square root of 9. Okay? So what's the square root of 5? Square root of 5. What's the square root of 9? 3. Sorry, I should have changed back to blue, but I didn't. Sorry about that. Now what? Yes. Seeing if you are paying attention. Now what? Add the 2/3. So x equals 2/3 plus or minus the square root of 5 over 3i. Questions or comments or anything on this problem? Ugly answer, but guys, the steps were exactly the same as the previous problem. Okay. Question? What else didn't do it about? No, you do your own homework. Don't be like your brother. I'm going to go ahead and start quadratic formula tomorrow. This is a good stopping point for today. So that'll be on the next video. Of course.